our first session after the welcome speech, and our first speaker from our first session is Pil Maria Salman from Eurodoc and Stockholm University with the speech to digital elephants in the room of academic practices. Dear Pil, the floor is yours. You're welcome.
Thank you. I will not be sharing slides, but I can share slides after the meeting and after the conference with you, and you can distribute if it makes sense.
Yeah, excellent, thanks.
And I think maybe you do not wish to share your WhatsApp. Right now, the screen sharing is a WhatsApp conversation. So my name is Pil. I have a PhD in theoretical quantum physics from Stockholm University. I'm a young scientist and I do my research these days within physics and within science and technology studies. Beside that, I am the current vice president of Eurodoc. It's short for European Council of Doctoral Candidates and Junior Researchers. And through Eurodoc, I am one of 7 co-chairs of a new Quara working group called focusing on research integrity and artificial intelligence. I believe that generative AI and AI in other forms are here to stay, and that it can be used ethically and scientifically rigorously in our scientific practices and our research practices. However, I also believe that it requires that we as researchers are much better educated, no matter what level we are at, in a myriad of different aspects. And it also requires that we as researchers take a societal responsibility. In preparing for this presentation, I came across a sentence in an article that surveyed the use of large language models in psychological research. The capacity of ChatGPT to analyze large data sets enables the identifications of patterns and trends in social data that may be challenging to discern manually. For example, ChatGPT can shift through social media data to identify trends in public opinions on various social and political issues. And what I want to highlight is, and what I will talk mostly about, is patterns and what patterns are. But the reason I highlight this is because of several reasons. First of all, I want to stress that generative AI, such as ChatGPT, is being used in research already. It's being used to generate new knowledge across disciplines, not just in natural sciences, also in social sciences and the humanities. And yet, as a young scientist, I have experienced that the focus on ethical use of AI within the higher education sector lies primarily in education or in our publishing practices as researchers, and not so much how we use generative AI tools or large language model in particularly in the core of our practices. And for that reason, I actually really want to thank the organizers of this conference, because this is one of the first opportunities I get as a young researcher to put focus not on publishing practices, or you can say the surrounding of research practices, but on the core of how AI will shape and form our role as researchers and how we do research. So thank you for being on the front with this, and thank you for the opportunity. The world around us is growing increasingly digital and data intensive. It affects us lives and practices as citizens and researchers in a multitude of different ways. And as researchers, we have to ask how we ensure that academic research remains trustworthy and transparent, as digitalization disrupts our practices and the use of black box AI is growing, also within our academic practices. However, the increased use of generative AI across scientific discipline, there is coming a need to address the question of what the use of artificial intelligence does to the epistemic foundations of scientific knowledge. And that's where what I will focus on in this presentation. Some of the epistemic challenges, by far not all of them, and not as much in depth as I would like to, when using generative AI in basic research or in applied research, and particularly in knowledge creation. First, I address the metaphysical problem of the existence of objects, of what it means that something belongs together, and in why this is relevant in the context of using AI in research. And secondly, I will probably not have time to address the question of bias, but I know others will today. The two questions above, patterns and bias, aims to highlight that there are some philosophical and practical, that there are both philosophical and practical challenges that generative AI brings to scientific research across fields, across discipline. And addressing these challenges is imperative if research integrity is to remain intact and if science is to be transparent and reproducible. From a pragmatic point of view, the use of AI brings many advantages and it is here to stay. So it is crucial that we adopt practices that support the use of it in a way that keeps research integrity intact. The conclusion and my outlook on this will be that using AI in research call for more openness in science and also more accelerated move to open data and open software practices, but also more education and training of researchers in how to do so, and not the least an inclusion into the research assessment as well. If I am to go to the core of this, then why I titled this the digital elephant is that the digital elephant in the room is that I think that we walk around this big object that we are not really addressing. And that is how the use of AI will change, like shapes and affects what we understand by knowledge. Before I dive into this philosophical question, I want to briefly outline how large language models are different from conventional algorithms. And the main in this is that whereas traditional programs can be viewed as a rule system, an algorithm that receives an input and then according to the rules gives an output, and is those explainable in the sense that we could reproduce the argument, even though that it will often be better, more efficient to use algorithms, use computers, use softwares. However, when we have AI, generative AI, and particularly because this is what is hot topic now, then generative AI is instead trained on large data sets. And during the training, the algorithm is changed and adapted in such a way that it becomes unexplainable and we cannot reproduce the argument that lies behind. And today, today what we build on is we use models that are built using an algorithm technique called machine learning models that are built using a technique called neural networks. And neural networks is a form of machine learning, and whether it's the kind that is based on supervised, unsupervised, or reinforced learning methods, then in all cases, pattern recognition plays an important role. When trained on a data set, the model will search for patterns. Information that was stored in the training data is inherited into the modified model. So when presented with new data, the model has now learned to process this data, and depending on the type of algorithm, can give you different forms of output, such as recommendations or solutions to optimization problems. However, the exact relation between the input and the output will only be possible to retrieve when the structure of the model is very simple or when the data set is very small. So in contrast to conventional computer programs, then these models will be opaque and unexplainable. In short, large language models are trained to recognize patterns in data, and based on the model, it will be able to process new data from an input form to a desired output. However, the patterns that the models are trained to recognize is an intrinsic part of the model, and they are most likely to be opaque. And that raises two important questions. What patterns are the models recognizing, and what constitutes a pattern? And this is not the same question. This is two very distinct questions. And it has ties to the question about what science is, and that's what lies behind all of it. What is science? And I believe that this is a question that every scientist, every researcher needs to ask oneself once in a while, but even more so right now if one wishes to rely on opaque machine learning techniques in one's research. In the context of opaque methods described above, there are especially two types of questions that I believe is necessary to address explicitly. And that is, what is the nature of the scientific explanation? To some degree, also what scientific understanding is, and what are scientific theories? How does one build and discover theories, but also what constitutes, what elements are the makings of scientific theories? And when the scientific explanation or theory relies on inexplainable deep neural network, then from the onset of the study, it is accepted that a part of the scientific argument will remain opaque. For the scientific explanation, this means that you are unlikely not only to reproduce the rationale behind it, that's the explanation, but that explanation is also rooted in whatever pattern the algorithm has identified. And this pattern, the pattern that is the constitute of the explanation, also remains opaque to you. Whether this is problematic and at what level it is problematic, that will depend on what field and what research area you are in. However, that you cannot tell how the pattern looks is only one part of the problem. Another part is the question of what the pattern is, what it constitutes, and what it represents. And there is no straightforward way to there's no straightforward way to answer this question. And I also want to underline that is in many ways very field and application dependent. However, I think a more in-depth discussion and understanding about the nature and the philosophical implication is needed if your scientific discoveries relies on neural networks. And the best way I can describe this and emphasize why is if we turn to Goodman's example of the color of emeralds. And it's in principle very simple. You envision that we encounter a new language, which has the word GRU in it. Something is GRU if and only if it is seen by someone and found to be green, or blue, but not seen by anyone. We know emeralds to be green in our natural language, but the ones we have seen and also the ones we have, both the ones we have seen, but also the ones we have not seen. However, in the new language we just encountered, those emeralds, the same emeralds would be GRU. This claim that all emeralds are green is incompatible with all emeralds being GRU, since the first entails that the unseen emeralds are green and the second that they are blue. And being both green and GRU is a contradiction. And the question about what it means that objects belong together is also a question about if there is a difference between green and GRU. Saying that we can define one pair in terms of the other is not enough, because we can also introduce bleen, something is blue if it is seen and green if it is unseen. And then we can define either green or blue in terms of GRU and green, or vice versa. This is an example that's taken from Goodman's new riddle of induction. And what I wish to highlight is the following. It's the question about what objects like GRU, bleen, blue, GRU, and green represent, and what they are and what they tell us about the world. When scientific explanations or theories relies on an inexplicable deep neural network, then from the onset of the study, it is accepted that a part of the scientific argument will remain opaque. In the context of the scientific explanation, then this entails not only that we cannot reproduce the argument, but we also do not know what objects' existence that the model has relied on. And it connects to metaphysical questions as well. This is an example that can be translated into basically any research field, not just a question about whether emeralds are green or GRU. And even though you do not necessarily prescribe to a scientific realist position where the elements you build, like the constitutes of your theories represents real objects in the world, then the epistemic question about the nature of the objects that your theory relies on is still one that you should address. Scientific explanation that we seek in physics is often assumed to actually require reference to a law of nature. Such reference constitutes an objective relation between the explanation and the phenomena that it is to be explained. And if we assume that laws of nature describe the actual world, then for scientific explanation to be meaningful, the reference in it, the patterns that the large language model recognize, they have to refer to objects that actually exist. But as the use of artificial intelligence is growing, you can also find interesting examples in other fields. And I will skip the question of bias, and then I will go. And what I want to highlight with this is that this is a discussion that we are not really taking at the level that we should yet. This is fundamentally to what we understand by scientific knowledge. And if we want to ensure that research, even in the age of AI, is trustworthy and reproducible, this is a discussion and this is some reflection that all researchers and all scientists has to be able to do to some level, at least within their own field. For me, there are 2 points that are absolutely crucial to stress, and that is that such a discussion becomes irrelevant if we don't ensure that the techniques that we are using are transparent as well. And that means that we have to move to more open science. That means that we have to train researchers better in open science, in the epistemic foundations of AI. And for me, the conference today is an important part of that training. That's a first step. 2 seconds. And it's not straightforward to change to open data. It's important to stress that open science, open data, and training and practices cannot drive it alone. It should be emphasized that the current lack of recognition of research contributions in formats such as data or code, or research that aims to reproduce, as has been mentioned before by the welcoming speeches, research results, is likely to act as barriers to the implementation of open science practices. However, it's at the same time, it's also worth to highlight that open research and open research data is likely to increase the use of the data and the use of the research, but it also adds more work for the researchers. Open science is by no means limited to open access publishing or open data. And it's important that when discussing open science practices that we think about all of it. It's by no means easy. Research is varied, research data is varied, and working with data and open science comes with a lot of ethical considerations. However, it's important that we address these challenges, and then to do so, we have to also emphasize that there's a connection to the current research assessment system. There's a heavy overemphasis on one metric in this system, and that has proved problematic. And that needs to be addressed. So if academia is to continue and research is to continue to be trustworthy and transparent, there's a need for more training, an accelerated move to open science practices. And I thank you for your time and for listening.
Pil, many thanks for your inspiring presentation about the role of generative artificial intelligence and artificial intelligence in our everyday life as a university teachers and researchers. Dear colleagues, it's time to have a discussion about this topic. Do you have any questions to Pil? Okay, I will start. First of all, many thanks for your presentation. I have a very simple question. For example, for Ukrainian universities and for Ukrainian teachers and educators and scientists, we have a very simple question. Is Gen AI good or bad for scientific
That depends. Life? That depends. It can be either. In many ways, it offers many new possibilities. So it can be good. But it also requires that we have a proper discussion. And I don't think that what I presented here today is enough in any way, but it requires that we have a proper discussion about what it does to our understanding of what scientific knowledge is, and not just to bias. We have a lot of discussion about bias, also a lot of discussion about the role data play, why we have to move to open science. But we also have to have a discussion about what is the fundamental, what is scientific knowledge, whether it is in physics, whether it is in psychology, whether it's in history. We have to have a discussion about how does the use of AI shape what we actually define as scientific knowledge. And here my understanding, my feeling is that if you come from a natural science background, you are not that trained in the philosophy discussion of it, what it actually, like, you are not shaped in having the epistemic discussion. And AI challenges some notions that we take for granted in the natural science about what knowledge is and what scientific method is and what it means to be able to provide an explanation and which elements we use in this explanation, which objects and what the meaning of the objects are. And if you're a natural scientist, you need to be trained in that, because you have to be able to provide that to the public outside of the university if they are to have faith in you, trust in you. And vice versa, I would say, and this is also why it was important for me to also say something about what AI actually is, because it's not just ChatGPT, it's an algorithmic method. It's machine learning. It comes in different forms. That's something that I see. I come from a natural science background, I should stress. That's something that I see people within the humanities and social science struggle with grasping. And somehow we have to train both groups, no matter your background, whether you're strong in the algorithmic understanding or strong in the philosophy understanding. We have to train such that we have a minimum level of understanding of the methods we use. If done so, I would say then AI presents many good opportunities, but it can, of course, also be misused, as everything else in research can.
Thanks a lot. My question was very simple, but very hard to answer it, because in Ukraine, for example, we have the mainstream of using of artificial intelligence. It's ChatGPT's generated artificial intelligence. Yes, of course, for other branch, we trying to use other AI tools, but for the educational activity, it's important to know what are the borders for the using of AI and Gen AI in honest way. Because on the other hand, we are ready to promote Gen AI as, for example, paper mill or essay mill tool. Yeah. But if you want to create some core, some content for our future educational course, if you want to analyze tables, graphs, so on, to create some code for new appliances, it's a good. But general direction for Ukrainian students, for example, is using of ChatGPT as an essay mill and ghostwriting tool. Yeah, that's why.
But I think that is a very general. That's a very general problem, I can say, academia faces all across Europe. How to use it well in education and how to use it well in research, and no one has found the golden solution. And I think, in that sense, this conference today is really important, because it puts focus on so many different aspects, and at least it brings us all to take something home and reflect upon it when we leave the conference. I would also say that, and I assume that it will be mentioned later, but projects such as Open for UA that aims at training like young scientists and scientists in general in Ukraine in open science practices, that also holds a great potential. And it doesn't have to be a fully fledged training in responsible use of AI. And I don't think that there's one definition of how to do so. I think in many ways it's also our own responsibilities as individual researchers and academics, teachers, like part of the, like you can say, the technical staff, is to actually reflect in our own practices upon this and settle what are proper uses. And it will vary depending on your task, your role, and also your academic field, what is reasonable and what is not reasonable. So thank you.
Yeah, Pil, thanks a lot. It's a good start of our conference with this topic, and I would like to give the word and give the speech to our next very important for us and for our Ukrainian students and educators direction. And with a great pleasure, I would like to invite Oneros Elauer. He is a leader of Knowledge Center and in Technical University in Graz. And his presentation had the title, "The Potential Impact of Generative AI on Open Science and Reproducibility." Dear Tony, due to the hacker attack, we have some moving of our time. That's why we are ready to know something new and something interesting about your speech. The floor is yours. Thanks.
Thank you, Artem, and no problem. Just let me set my timer. I have about 20 minutes to talk, Artem. Am I right?
Yeah.
Give me 1 second. Okay. So today, I am happy to talk to you about the potential impact of generative AI on open science and reproducibility. So obviously, generative AI is big news everywhere, but especially given our wish to kind of improve research integrity, the openness of research, and ultimately the robustness of research, the ongoing kind of efforts in this direction. ChatGPT and other generative AI technologies seem to me to have clear potential implications, both pros and cons, for these reform movements. So I'm happy to talk to you about those today. So since September of last year and the release of ChatGPT 3.5, there's really huge attention in the potential for AI technologies, large language models, to transform workflows. So maybe no need to go through this, but generative AI is a class of artificial intelligence capable of creating new content, including text, images, music, other forms of media. Trained on large data sets, they learn the underlying patterns, styles, and rules. And they produce not only analyses and interpret data, but also produce new outputs. So there's a creative generative element to them. Unlike some other things, when GPT was first released, it reminded me very much of the explosion in interest around blockchain, which very often seemed to be a solution looking for a problem. There's real substance to the hype of ChatGPT. Recent working paper from Harvard Business performed randomized experiments with management consultants, high-level professionals who were completing realistic, complex, and knowledge-intensive tasks. They were given a task to design a new marketing campaign for a training shoe, I think, and within this task, so given this creative task, where the technology was known to perform well, the speed at which they completed that task increased by a quarter. The rating of the quality of the output that they gave, rated independently by human reviewers, was 40% increased quality of the performance, and they completed. They had 10% increase in completing tasks. But there was another task, another experiment with a task where the technology was known to perform less well, and there was almost a 20% decrease in the correctness of the results. You should read this paper; it's very interesting. So there's substance to the hype, and there's also it's a quickly moving area. There's a huge explosive growth in the number of parameters, the size of the training data sets that are being used, but also in the capabilities of these technologies. And what's interesting is that the models exhibit emergent capabilities. So they don't just comprehend text or are able to predict the next word in sentences, but they show qualities of domain specialism, ideation, text summarization, and reasoning in areas which they haven't been specifically trained for. So, for example, they weren't specifically trained to be able to pass the US bar exam for lawyers, but they're able to do so. And what's also very interesting is that their capabilities are often identified through user interaction. So users using prompts to find out new capabilities, such as their ability to solve logic problems if you ask them the question in a specific way, asking it to think step by step. And so this paper from Harvard Business talks about there being a jagged frontier of AI capabilities. So we don't know where they perform well and where they don't. Finding out which side of that line we're on at some times is challenging. Tasks with the same perceived difficulty may be on one side of the line or the other. And finding out where we stand with the technology and how to improve the technology, of course, is something where the user has agency. So regarding the potential for these technologies to transform research, there was a Delphi study conducted recently, which highlighted the transformative potential of large language models in science, particularly in administrative, creative, analytical tasks. And there is also already a range of experimentation and a lot of papers coming examining whether these tasks are good to be used in research design, ideation, information retrieval, evidence synthesis, assessment, textual analysis, development of coding and analysis scripts, and dissemination. But there are potential downsides, and this comes at a time when we're addressing what's termed in a lot of disciplines as a reproducibility crisis. So systematic replication, prevalence of questionable research practices, and lack of transparency are seeming to show that the robustness of our scientific results are really in question. And so with aligned movements like the push towards open science and improved research integrity, these tools are entering a picture where we're trying to fix a lot of problems with research. And maybe these tools help us fix those problems, and maybe they make them worse. And that's what I'll talk about today. Just to define what I mean when I say reproducibility, this is really just at a very high level when I use the term, it's just obtaining consistent results if you repeat experiments, studies, analyses. And yeah, to underline the point, this reproducibility is in question. A lot of causes: poor methods of reporting, poor design of studies, inadequate sharing of data, code, materials, lack of standardization in the way that experiments or studies are conducted, in the equipment that's used, in the analytical methods, a lack of incentives for doing reproduction or replication studies, publication bias. So we're kind of incentivized to publish positive results rather than null or negative findings. And obviously this biases what appears in the literature. A lot of issues of questionable research practices. So aligned with these kind of poor incentives, researchers are often incentivized to go looking for those positive findings. And so in a lot of disciplines, there are issues with p-hacking, which is just looking for a statistically significant result, hypothesizing after the results are known, hacking, which is telling a nice story to say why the statistically significant result that you found, which might be a false positive if you have really tortured the data to find it. Telling a nice story for why this is theoretically reasonable, and issues of data leakage, along with biases and just constraints on time and resources for researchers. So I'll talk, I'll go through a couple of examples of where these tools might help and might hinder, and you'll see that kind of this notion of the jagged frontier, which side of the line we're on, kind of how these tools work well or not, as well as kind of the pros and cons of their use. They really do have potential to help us in kind of making results more robust, but they also have the potential to do harm. So first, to talk about documentation. We said that Delphi study, where I said that Delphi study had highlighted the potential to help with administrative tasks, quote unquote. And of course, ChatGPT and others, these are text generation tools. And a lot of methods reproducibility, that is enabling in principle studies to be reproduced, is just about good documentation, just about putting into human understandable forms and machine understandable forms the processes that led to a specific scientific finding. Within AI research itself, this paper from Gundersen and Kensmo delineated 3 different types of reproducibility, but then also looked at the AI literature itself. And there you can see that the levels of transparency and sharing of the experimental code, predictions, hypotheses, results, and research methods are often very low. You'll see that the training data is shared only in about 50% of cases, and levels of code sharing, and AI systems are code, is very, very poor. And where code is available, it's often just pseudocode. And so this obviously is partially a problem of incentives. Sometimes we're not incentivized to share because of competition. And sometimes we're not incentivized to share just because it's extra work that we don't have time for. And so where it is the case that it's an issue of extra work that we don't have time for, then there is potential for these technologies to support us, for example, in writing data management plans, in documenting properly and fully our code and our data, and so on. There's an issue with large language models of thinking of reproducibility, of course, especially the ones with which we're most familiar, is that very often they're not very open themselves. And although ChatGPT comes from a company called OpenAI, it's actually the least open model available. So there's this resource which is kind of tracking openness of large language models. And even amongst those that claim to be open source, there are real issues. So the training data is very often obscure. And sometimes this is due to legality reasons. I guess there are disincentives to share if you're not entirely sure that using that training data was legal. There's very little in sharing of the enhanced training that goes on top, the reinforcement learning from human feedback. And there's often very, very poor, careful scientific documentation of these models. And I think that if we're thinking about how these tools might help in the fight of reproducibility, it is very important that the reproducibility of the tools, the models that we're using are themselves as reproducible as possible, especially given issues of bias or in training data, for example. So there's potential to assist in documentation. Reproducible research needs resources, as I already said, and fully documenting all elements of research workflows puts further burdens on already constrained time and resources. And large language models could, and here I say could, there's a lot of experimentation in various elements of this, and this will shake out, and some of, maybe it will be able to, maybe it won't be a cost-effective solution for some of those things, but there's a lot of experimentation. It could assist with a lot of documentation tasks, data management plans, protocols, pre-registrations, code documentation, and creating metadata for all those materials. But of course, having this tool available won't automatically overcome the cultural and economic issues that prohibit sharing. So we have to work further on realigning incentives and so on. But there's a key issue that because so much open science, open science is very often based on carefully documenting what happened. But up to now, it seems to me there's been just having stuff available has been kind of the aim. The quality or checks on the quality of what is available has not yet been enough in focus. And because these systems are generative, there is a real possibility that they will just help create fake or manipulated documentation. So there was already a paper in a medical journal earlier this year, which showed that they were able to use a large language model to create a data set which supported a specific hypothesis. So there are lots of reasons to create fake data, good reasons sometimes. Having synthetic data where other data isn't available can be helpful, of course, but being able to synthesize data which supports a specific hypothesis would mean that you were able to, say, publish that study and say, hey, but my data is available. This paper, the data it created didn't really pass in-depth scrutiny by experts. So at the moment, it's not such an issue, but it will become an issue. These tools are developing so fast. This will become an issue. And I think there is the possibility that the kind of documentation aim of open science is made very problematic by the fact that these tools will be able to assist to create fake documentation. And there's also the issue that we need to be wary of the biases and inaccuracies that are encoded in these systems. So just to talk about the limitations of the systems, there's two main ones. So this paper by Bender et al. Talked about large language models as stochastic parrots. They aren't really understanding, in my view, understanding in a true sense the nature of the words that they're stringing together. They're prediction machines, and they or plausibility machines, which guess the next most plausible word to put after the last word. That's kind of the and that achieves incredible things, but we shouldn't mistake what they are. And so there are real issues of correctness of what they return. So if you ask a large language model a question, it isn't directly interrogating databases of facts. It is looking to the model of interrelations of parameters that it has created. And this can mean, because it's just putting together the most plausible terms and it lacks understanding of the underlying meaning, that it can string together seemingly sense-making text, but that is what's called sometimes hallucinations, plausible-looking text that's just plain wrong. And then there are issues of bias, of course, of that the tools will just parrot back to us what they've learned from the data. And there are obviously issues of how representative that data is. So this is very heavily on text, which is curated from internet sources, and the visibility of certain demographics, regions varies a lot, obviously, and who is then training that data in order to put in, so who's giving it feedback, further kind of encodes the values or the worldviews of the people doing the training. And there was another paper which I don't mention here, but it looked at kind of the values inherent in large language models. There's a thing called the World Values Survey, which runs in every country, and collates kind of world values across the world. They ran this survey 1,000 times in ChatGPT, and then took the averages and looked at which country's values it aligns most strongly with. And obviously those values, and as expected, these values are those of the kind of global north countries very often. So moving on, and I'll go through this a bit more quickly. The problem of dissemination of research and issues of reproducibility and research integrity. So we live in a publish or perish culture. And this has meant that at the moment, there's a very big problem of paper mills who sell authorship on papers. So some institutions in many countries are specifically incentivizing authorship on papers which are in journals, usually journals indexed in Scope of Web of Science. Very often this means that these paper mills are creating fake papers, and these papers are then funneled into index journals through disreputable means, peer review rings, laxly controlled special issues. And there are a huge number of retractions underway at the moment. Last year, Wiley and Hindawi had to retract more than 1,200 papers because of this issue. And it's actually led Wiley to discontinue the name Hindawi. This has basically affected their reputation so much they can't continue to use the name Hindawi. So it's a really big problem. And large language models, because they generate text, obviously, and if these paper mills are in the business of generating papers as easily, as quickly, as cheaply as possible in order to sell authorships, then large language models do pose a threat here. And we are seeing kind of the use of large language models, the visible use, already occurring in academic papers. So this, very often, if you ask LLM to perform a task, it tells you, look, I'm only a large language model, but here is the answer that I can give you. And this specific text as an AI language model is appearing in the literature. It used to be that open peer review was an answer to this threat. So basically, with peer review rings or kind of poor special issues and literature that hasn't really gone through scrutiny appearing, getting published, one solution was to publish the reviews, because obviously if the problem is that no peer review has been performed, publishing the review shows that where it has and hasn't been performed. But generative AI can certainly create plausible looking fake reviews to accompany fake articles. So you can see there how large language models both kind of exacerbate a problem, but also kind of change the nature of one potential solution. Yeah, I'll skip this because I think I need. So just to wrap up, overall, large language models would probably be highly impactful, need careful testing and implementation, but most are actually optimistic. So in this Delphi study, most think that the advantages will outweigh the disadvantages. I think the same. I think we need to embrace these models and find out where they are useful in our research, but we shouldn't embrace them uncritically. They offer a promising tool set for various research tasks, but we need caution In negotiating the jagged frontier, we must be careful, especially where capacities and fallibilities are unclear. Over-reliance on outputs without verification could compromise reproducibility and reliability. We should prefer truly open large language models to support scientific research. And trust in these tools will take time to establish and to be earned. And in the meantime, we should keep the tools at arm's length. We aren't thinking through these technologies. We're thinking with these technologies in dialogue, and kind of this critical assessment is necessary. So thank you. I think I ran a little bit over, Adam, but sorry.
Yeah, Tony, many thanks for this point of view, because usually we use, for example, ChatGPT as a part of large language model for very ordinary purpose, to create some text. And there are no any thoughts how it will be inside and how it will be after. Yeah, and your point of view and your presentation, it's some kind of light for us, what is really important, and what will be created by the large language models. And thank you for your excellent presentation. As usual, yeah, you open some other horizon for us, some connection between open science and artificial intelligence. We know that we have some bridge between academic integrity and artificial intelligence. It's some kind of policy of using of different tools of AI. But now we have a new horizon. Dear colleagues, do you have any questions to Tony? Okay, as usual, I have a simple question, but maybe it's also a provocative question for understanding, for deep understanding phenomenon of open science and relation with artificial intelligence. You told about the open version of ChatGPT 3.5. What is your opinion? Is this ChatGPT is open software? Is it open tool, or it's some kind of, I don't know, semi-open? Because we are able to use it openly, but we are not able to go inside this ChatGPT or other large language models. What is your opinion about this?
I don't think it is open. We don't have access to the training data. We don't know how it was trained. We don't have access to the models themselves. And there are, as I say, real issues there in terms of our potential reliance on these tools. So the number of services which are now building on the OpenAI application program interface is huge. Just recently I saw that one of the tools for qualitative data analysis, Atlas.ti, already incorporates ChatGPT to encode. And as I said, the biases that may be encoded in these systems, the ways in which they may return good results or poor results, are not fully understood if the systems are not transparent. And this is why I really think that as an academic community, we need to clearly try to prefer using open models wherever possible. Yeah.
Of course, thanks a lot. My question was provocative, and I heard a good phrase from you. How it training? Yeah, and it's very important, because we have the opinion that all documents, all data for training of ChatGPT was used by the, for example, different open licenses. But is it reality? Because we didn't know, and we don't know what is the base of this ChatGPT. Yeah, and in this case, maybe ChatGPT have their own texts at the point of view of appropriate using of Creative Commons licenses, because we didn't know what the texts are in the core of his training. And really, in the epoch of openness, we are ready and we are able to use all tools and academic and artificial intelligence, also all tools which are open. But we have some restrictions, and maybe some restrictions are in our minds, because using of ChatGPT has some ethical problems. It's open for us to use, it's closed for us to reconstruct or to change, but it's closed for us in terms of academic integrity for using, for example, as a paper mills.
Okay.
Yeah, Tony, thanks a lot for your presentation. It was very interesting and some new horizons for us. Okay, let's move to the next presentation. It will be, I think it will be more technological, but it's still very important for us, because it's our mainstream in Ukraine during the accreditation process to use different similarity checkers for preparing our educational and scientific works. But we have a new challenge. We are talking about who is the author of this text, AI or generative AI, or the physical body. Yeah, and in this case, with a great pleasure, I would like to invite to speech Ali Takhmazov, who is the executive director for international market in the company Plagiat PL, with the topic AI content detection and assessing tools. Ali, the floor is yours.
Hello, everyone. Thank you for inviting. I decided not to make big presentation, as I usually do, but to focus on the certain most important things, which related to the expectations of the universities in terms of the AI content detection. We, as a service providers of anti-plagiarism system, we also face with many, quite often, requests to provide any technical solution to detect AI-generated text by the teachers or the students, and it's quite difficult task. Of course, there are many anti-plagiarism providers in the world. I will not promote them, but all of them, currently promoting their solution or declaring that they have solution and promoting it. And there are lots of critics about that. Critic that the solution doesn't work, that the scenarios of AI, the scenarios of generated text there are so many scenarios. It could be paraphrased AI generated text, paraphrased by the human. It could be human written text translated by the machine. It could be mixed human and AI text, and how to detect how to identify and detect the human impact in this text, whether the text already it's stopped being human, and or it's questioning the independence of the paper. So it's because it's all related to the independence of the paper, whether it's human written, or it can question the knowledge and the skills of the student, and the paper stop being, let's say, own or so-called independent. So we created a tool that on different, we were thinking, of course, because we had to react on those requests somehow, and because and there are many reasons. Also, the subject is very new, and we didn't know in which direction to choose. We also look at what our competitors are offering on the market, and we see that actually, when we look at the offer of our competitors, an offer, it ends up only on some score. So a so-called AI score, whatever. Like every provider has its own title for this, let's say, indicator. So they call it AI score, whatever score, which detects AI, let's say, impact in the paper. The score, of course, is not reliable because there might be different parts of the paper written by AI, and those fragments could not be, copyright subject. And how to treat this AI score? To rely on it, to add it to the procedures and disciplinary actions. I mean, the universities are searching for the technical solution, but they at the same time, of course, they implement, some other solutions, which pedagogical, I would say, to prevent of using to prevent of misusing AI. Right? But we made this tool. I will show it to you on the screen. So it's a test paper. We made it. We made this type of tool that shows this part showed once again some score, AI score, which I think, or which we think cannot display the whole picture of AI use in the paper, because of objective reasons, right? But then we decided to go step forward and show more details about the content that we could grasp. And what we do, we create another report. Within the same report, we have another report where we divide all the paper on the fragments and coloring the fragments, basically reflecting the likelihood or probability of AI in this text. So if the text is red or dark red, then the AI probability is higher, or let's say the probability that the text is written by AI is higher. And if the text is yellow, it's lower, let's say it's middle, and the green is low. And then, of course, you can ask me the question, why more than 60% is higher? Why it's not 50%? I mean, the subject is new. We're just entering the new era, and we are trying to calibrate what never been created and invented before. And this calibration, of course, will take some time. But at least we try to step forward to show a bit more, not only the score, but also the fragments that might be suspicious or might be treated as suspicious, to make more detailed analysis later on. Because if you just look at the percentage, it looks terrifying. But at the same time, you could look at the fragments which were found as AI, let's say, with a higher likelihood of AI. You can go through not all the paper, but through the certain fragments, and look in details, talk to the student whether whether the content that found with higher likelihood of AI, whether this content is a subject of discussion with the student or not, because it might be the information like generally available information, or the student could quote somehow, because there is already a practice of quoting AI-generated text because of certain reasons, so that the paper would be independent. Yeah, it's also the subject of debate, but there is such direction that a university decided to force students to quote or credit the text created by AI. So when you see the red text, this could be a subject of discussion, or it might not be, right? But we don't want, what we want is, if there are any rules that adopted by the university, for example, that you have to quote those fragments, then our system could help you to identify the, let's say, fragments which our system and our algorithm considers highly with a high likelihood of AI. There is a lot, I would say, magic behind it, because this algorithm, it was tested many times in different languages, not only in English, of course, but also in German, Spanish, Ukrainian, Polish, of course, and many other languages from the different perspectives, like mixed text or translated, etc., and even by the president of NI, Tomasz Poltinen. And many experts confirms that our detection tool, AI detection tool, works quite well, comparing even to Turnitin. In many subjects, in many perspectives, it's quite effective. But once again, it cannot be, it's not ideal solution. We already have cases when university use this tool and set some threshold value for similarity for AI AI content probability score, which we completely disagree with, because it has no sense. But once again, there could be a good and bad practice, and we need to definitely promote a good practice and very accurate use of this tool, so not to harm the student rights, and because this tool has some level of credibility, but at the same time, we have to be very careful when it comes to the technologies that emerged just recently, and we still need the time for calibration. The most important information was already provided by me, and if you have any questions, I will be happy to answer.
Dearly, many thanks for your presentation. It's a technological presentation. It's some kind of algorithm for us. We have the LM tools, but now we have anti-LLM tools. Yeah, and what is the main reason to have these services in the different similarity checker programs? Not only in the similarity checker programs, but at all. yeah, we have not good relation from, for example, Soviet Union, where we were able to use all things, all texts. Yeah, we have in Ukraine, we have more than 20 years of independence, but we have some kind of history, and using of Gen AI is something new for us, but is we are lucky that we have it. We are lucky in the point of view that we are able to create something new and to use it for the right and correct purposes. But as we said before, we have the problem. We have a problem. As I remember, we have one proverb that academic misconduct is about lazy liars. Yeah, lazy people are ready to have new tools. Yeah, and in this case, we are ready to present that we have anti-tools for promotion of academic integrity, of course.
I would even add there is another problem behind it, that in like student academic environment, it was already quite well rooted. The practice of using SMUs, and the practice was rooted that deep, passing from generation to generation, that this is a normal practice, or passing the paper from hands to hands, so that this kind of a behavior, this kind of bad practice, now converted, let's say, has new tools like AI tool, which is ideally matching this environment, ideally suiting this environment. And I would say that the core of the problem is not the using of AI or misusing of AI, but fighting with the bad practice. And the student have to understand, but especially in Ukraine, where very little number of students are disqualified because of plagiarism. And because I had to deal with many workshops where students were confirming that actually teacher told us to copy from the internet. What do you want from us? I heard a lot in this kind of conversations. And well, I mean, mentality of the teachers have to change. They have to understand that there's no more, it's acceptable. And at the same time, there should be some actions taken by the universities and administration of the universities, also including the procedures. Yeah. Thank you.
Yeah, exactly. And we should ask students what they want. They want to gain hard skills or soft skills and success in their education, or they want to obtain the diploma and diploma supplement with the marks A, B, and this diploma will not be useful for example, for employers, because it's not really a diploma with a description of their skills. And in this case, maybe they change their mind from the diploma to the quality of assessment works. And in this case, AI detection tools maybe are good for the promotion of academic integrity, and some kind of the barrier between the misconduct and honest education and honest environment.
Yeah, this kind of conception is not working anymore. I think the students came to the university to gain the skills. They understand, and it's everywhere in the world. The diploma never shows the gain skills, right, and knowledge. So just like in Ukraine, it's normal practice that the students get the diploma, but the thing is the quality standards at the universities not reflecting, the standard that have to be, especially in the academic integrity. I mean, the academic administration have to consider it and treat it seriously.
Yeah, now diploma is like the evidence that students are able to come to university and spend 5, 6 or more years at the university. But it's not about the hard skills and soft skills. And we are ready to rebuild the mind of our students that they are here at the university because of the perspectives of obtaining, of gaining of new skills. Dear colleagues, do you have any questions to Ali?
Yes, I have some question.
Yeah, dear Natalia, you're welcome.
Can an author's own scientific text, overloaded with scientific terminology, be identified as written by AI?
It's a very difficult question. I mean, should not be. I mean, you can try and test, but should not. I mean, the system should detect and identify the text written by AI, right? And it's written by the human. It should show you that the impact of the AI is low. It's human generated. Like this should be a logic of the algorithm. If it's stepping out of this logic, then we have a problem. And yeah. And what is also important in Ukraine, I would say, I would like to remark, because we notice that at many university web pages promoting essay meals, maybe unconsciously, but that what happens. And it may happen that the same universities will be promoting the misuse of AI. So it also should be tackled by the academic environment, academic society, investigated and raised. Yeah. Thank you.
Thank you, Ali. Do you have any other questions, dear colleagues, dear participants? Okay, let's move to the next presentation, and I want to give the talk, and it will be with a great pleasure to Irina Kuchma. She is a representative of EIFL with the talk Institutional Action Plans for Open Science. Dear Irina, the floor is yours.
Thank you so much, Artem, and good morning, good afternoon, dear colleagues. I would like to share some learnings from the process of creating institutional open science action plans. A couple of years ago, UNESCO introduced the first international policymaking instrument for open science, UNESCO recommendation on open science, and to support the implementation of those recommendations in national and institutional contexts. An open science toolkit was created that includes a number of checklists, good practices advice for university leaders, for policymakers, for open access publishers. And one of the topics that will be included in the checklist is how to create an institutional open science action plan. So what I'll be sharing with you today are the materials that will be part of that checklist, because I was part of a writing team, and it was a great pleasure to collaborate with colleagues who went through this process. So some basic tips when you start preparing for an institutional open science action plan, think who will be a driver, an individual or a unit who will own this idea, lead the development or implementation, and then most likely that unit will also monitor implementation. And of course, all that needs to be backed up by institutional leadership, because then developments will be faster. Then that leader could set up a working group, and the wider representation is in the working group, the better it is, because then it could help with smoother adoption and integration in institutional workflows. And then another important element is to think how open science developments are aligned with institutional values and mission, because they shouldn't be just generic things. They should really be the areas of activity that would help an institution to do what it wants to do. And these are some of the values and principles from UNESCO recommendation. And you see quality and integrity is the first one, and we discussed a lot about that today already. Then also collective benefit, equity and fairness, diversity and inclusiveness. I think it would be a useful exercise to go through these values and principles and see how they are aligned with an institutional values and mission. Then another activity is to start writing the scope and objectives. And as we heard today, the scope of open science could be very broad. It could include open access to publications, research data management, open data, open source software, open hardware, open educational resources, engagement with society, and many other areas. And that's a question for an institution, whether it would to focus on all of them, or just some of them, or to start with some of them and then gradually move to the others. So that's also an exercise that could help with the planning. And then it would be good to write specific objectives for this open science action plan, and remember that those objectives should be really measurable. And what's also important, that they should be implementable. So they shouldn't be something that it's hard to do in current circumstances. So it's better to start with maybe less activities, but done properly, than a huge framework that is really hard to implement. Another area, and many of us are also involved in these developments, as we have seen from developments in the past, it's really hard to implement especially open access, but also open science, without changing approaches to research assessment. And these discussions about open science policy and also research assessment should really go hand in hand, because if an institution really wants to implement open science, then that institution should really incentivize quality research, should reward open science behaviors, should recognize diversity of research outputs, and shouldn't only look at publications in high impact factor journals. And a lot of aspiration could be drawn from San Francisco Declaration on Research Assessment, which says that impact factors for journals are the tools to use when assessing researchers or institutions. And then it's also great to see Ukrainian chapter in QARA, and also many other national chapters. So I hope there will be positive developments on that front. But research assessment is also something that an institution should be focusing on while thinking about open science. Then another area which is, I think, even harder than change in research assessment is intellectual property management, because again, if an institution wants to embed open science practices, then an institution should revise institutional policies on intellectual property rights management, and open science should be included there as well, and open licensing should be mentioned there, or public domain, if some research outputs like research data, for example, will be made available with public domain dedication. And then another important area, and we see that happening a lot in the UK, in Ireland, but also in many other universities, where universities started introducing rights retention policies and strategies, saying that it's either an institution or researchers who retain sufficient intellectual property rights to provide open access, and they only license to publishers specific permissions to make article available, and they also ensure that their research results are available under open licenses. Another complicated area, and I think it's especially complicated in Ukrainian context, those public-private partnerships that university signs with industries, and in our context, it's really defense industry, and it's hard to say whether a lot should be open in that area or not. But even aside from those developments, that's still a huge question, how universities could practice open science and at the same time benefit from commercialization activities. And we've seen some exciting developments in Canada or in Denmark, where there are collaborations with the industry when results are really shared openly, but usually those collaborations are back up with public funding because someone has to pay for that. And I think that's also a big area. And another big area is, of course, that when this kind of public-private partnerships are signed, it's important to ensure that researchers retain sufficient amount of ownership of their research results, that this unfair or inequitable profit isn't happening from publicly funded science. And then another set of policies that institutions need to revise are the policies around data governance, dealing with sensitive data, and other areas. And that's an area where legal advice is really needed. Then training, awareness raising is really important if open science needs to be embedded in institutional practices. And it's also important, and it's related to research assessment, that human resources criteria should be also adjusted to open science requirements. So, for example, job descriptions, performance appraisals, promotion criteria should really take into account how staff practices open science. And that's also an area where different contributions to open science activities could be acknowledged, because writing articles is not the only open science activity. There are also public engagement activities that should be rewarded, participation in collaborative and team science versus rewarding individual accomplishments. And for that, this credit taxonomy is a good instrument where different roles in research process could be recognized and acknowledged. And I included a link to the recent policy from Glasgow University, Code of Good Practice in research that included this credit taxonomy to enable recognition of multiple types of contribution to research. Then open science infrastructures is a huge topic, especially for us in Ukraine now, and maybe it's not the area where a lot of activities could be happening right now, but it's good to keep in mind that whatever infrastructure is used, it would be good to make sure that it really matches this criteria for interoperability and accessibility. And then if there are procurement practices in an institution, it would be good to align them with open science principles and values. For example, maybe prioritize as far as possible open source software stacks when digital infrastructures are procured. And then topic of persistent identifiers is really important because they help to connect different research outputs together. And in Ukraine, we have ORCID consortium, so it's easier now to integrate ORCID identifiers in institutional infrastructures. It would be good to ensure that DOIs for research outputs are used, at least when they are available, that they also mentioned in repositories when published journal articles are deposited. And then it would be good if raw IDs are also used in infrastructures, because I think now all Ukrainian universities have them. So it would be good to use them and to ensure that connection between research outputs, people who created them, and institutions that contributed. Societal engagement is also an interesting area, and I think especially in our Ukrainian context, and that's another kind of audit that could happen at the institution to see what's already going on with societal engagement, and then try to promote an institution as an active partner in citizens and participatory science projects, and then also develop workflows, how participations in those projects could be rewarded. So some kind of guidelines on institutional level could be issued to support researchers and also citizen scientists, ensuring that they all follow proper methodologies and policies. And then maybe that's an area where students could also be engaged, because they could be also research partners in this kind of participatory citizen science projects, and that could be one of their course assignments, for example, and for them it would be a real in-person experience, but in order to do that, students have to be trained appropriately, and they also should be rewarded for that, maybe receive some kind of credits for participation in this kind of projects. I also included 2 examples of institutional open science action plans in English that are good ones and could be reused. And that's a list of people who contributed to this checklist, which will very soon be available in the UNESCO Open Science Toolkit. So thank you so much, and I'll be happy to answer any questions you might have.
Yeah, Irina, many thanks for your presentation. It's a good on the practical point of view. Yeah, we are knowing something about the theory of academic integrity, open science, so on, but we should have the action plan. Grigory Mazalevich in his welcome speech marked some documents, some algorithms about the implementation of open science in Ukrainian scientific and educational landscape. and your presentation is the different way to promote all these values of academic integrity, open science, so on, by the not promotional items, but maybe more by the action plans. And it's good for us because we are able to see what should we do from this time to that time, what are other actions during this time frame, so on, so on. In this case, many thanks for your presentation. It's other point of view on the connection between all our conference topics. Okay, we are ready to ask the questions. Yuri, please.
Thanks, Irina, thanks for your insightful presentation. And like, it's a question for a person who definitely familiar with the broad context, and I'd like to maybe use this opportunity to get some insights from you. How do you assess the state of citizen science as a concept in Ukraine? How widespread is it, and how much of that is in there in Ukrainian context? Maybe you have faced it somewhere, because on my opinion, unfortunately, it's not still on the so broad spectrum for now.
Thanks a lot for your question. I'm familiar with some aspects of citizen science in Ukraine, which are related to biodiversity, because I live in Kyiv, and in Kyiv we have Natural Sciences Museum that has a head of the department who is a very active leader for citizen science projects around registering biodiversity of species, also tracking invasive species in Ukraine. And I think actually in Lviv also, Lviv Museum of Natural History is also active. They think they collected, they worked with bird watchers communities, and they recorded some voices of birds with the help of citizen science. I was also a part of tracking species in Ukraine that are included in the Red Book. There was a process when there were observations of in my case, it was birds, because my sister is a bird watcher. That's why I'm involved. So we tracked some activities around migration, and it helped to identify some species that are considered to be non-existent, but then they actually still exist in Ukraine. And I'm sure that there are the similar projects, but I think the problem is that people involved in them are not really connected. For this biodiversity tracking, there is a Facebook group, and it has thousands of people. But for other areas, I think there are other areas, but we just don't know about them. And I don't know what could be done to get a better knowledge. In some countries, in Latvia, for example, citizen science is a part of national open science action plans, and the ministry keeps a record of, keeps a list of citizen science projects in the country, and try to connect people together to learn from each other. Also, in other Baltic states, libraries are involved. They provide training to citizen scientists, and they also offer libraries as spaces for meetings. So I don't know if Oksana is here. Maybe that's one of the areas that Ukrainian Library Association could get involved and try to collect information about that from the members. And it's also part of National Open Science Action Plan, so maybe there will be some activities on the national level.
Yeah, we definitely hope for that, of course, especially in natural sciences. That would be great. Yeah, thank you very much. Thank you very much. That pretty much answers all my questions. Thank you.
Dear colleagues, do you have any other questions? Okay, dear Irina, thank you so much for your presentation, for your insights, for your actions for us, for Ukrainian universities, and for other colleagues. It was very interesting for us, and it's some kind of action direction. Yeah, because it's very important for us to implement. Yeah, yesterday we had a very significant decision about the way of Ukrainian way to the European Union, and now we have to create a good environment to achieve the goals and to realize the main terms, the main features to be involved in the European Union as a full member. Okay, let's move forward. And our next presenter is Alexander Bereska. He's Director of President of Institute for Open Science and Innovation. He is a project leader of two big Erasmus Plus projects, Optima and Open for UA, and he has a huge experience in promotion and construction and creation of open science environment in Ukraine and abroad. Alexander, the floor is yours. You're welcome.
Many thanks, Artem. I hope you can hear me.
Yeah.
Yes. So, right, let me share my screen. So, first of all, many thanks for invitation, because, of course, this topic is super relevant for today's Ukraine, not only for Ukraine, of course, but for the whole world and for the whole academic society, but especially for Ukraine, which faces very like huge challenges nowadays. And one of the questions which we should ask ourselves, of course, is how can we use academic community, how can we use research, how we can use education to build Ukrainians' resilience and help us not only survive, but also build our victory, all right? So, in 2021, I was actively engaged in EuroDoc, the European Council of Doctoral Candidates and Junior Researchers, and I know that the first presenter today was Pil Maria Saugman, who is now Vice President of EuroDoc, of course. And we were planning a conference in Lviv, Ukraine, EuroDoc annual conference. This was not the case, of course, because the full-scale war emerged. And this conference took place instead next year, 2023, in Uppsala, Sweden. It was total success, everything fine. But what is important that our topic for our conference in Ukraine was research culture, because EuroDoc's vision is a fair and sustainable research culture, right, where early career researchers are treated with respect and have access to stable and sustainable career pathways. So what is a research culture, right? And there are quite several definitions. One of them is probably the most popular from the Royal Society from United Kingdom. So research culture encompasses behaviors, values, expectations, attitudes, and norms of our research communities. So actually, it influences everything from career paths to how research is conducted and communicated. So basically, research culture is the way research is organized and performed, right? And recently, if you speak about the United Kingdom, probably many of you know that in the United Kingdom there is a very comprehensive research assessment system, which is called the Research Excellence Framework, or REF. And they are now planning to conduct this research assessment in 2029, and they still have much time to prepare. And what is in the news is that actually they will start assessing research culture and open research culture in the next generation of REF, and it will have like quite important coefficient in the general assessment. So if such a comprehensive and sophisticated organization as REF is taking this into account, let's discuss what is it and how we can also move in this direction. So this is a quotation from Brian Nosek from 2015, but to be honest, I think that in most countries, not many things have changed. So of course, if you ask like a researcher, or like regular researcher, if they think that openness is good, if they should try to make their research outputs like, I don't know, reproducible, everyone will agree with you. But when it comes to practice, then there are many different many different restrictions. So, and this means that while on awareness level, there is already like some nice progress, so at the practices level, the cultural level, we still are lagging behind. So what is needed to implement change? Another quotation of Brian Nosek today. So there is a well-known pyramid of implementing change. So what is needed, right? So first of all, of course, we need infrastructure. So to make it possible, because without infrastructure, it's impossible to do anything. Then make it easy, nice user interface experience, make it normative when communities, it's this grassroots approach, right? Then communities generate best practices, they document them, they shape, different groups and try to bring it further. Then we have incentives, probably on institutional level, on national level, whatever else, and then we have policy, right? So that's an ideal approach. However, let me tell you that in many environments, this ideal approach is unfortunately unreachable because of the lack of many like parts of this amazing pyramid. And of course, there are lots of difficulties with such an approach in Ukraine. But okay, so let's try to understand what still can be done in the situation of very limited resources, with the situation of war, and many other challenges that Ukraine is facing now, right? What still can be done? So what is open science? It's transparent and accessible knowledge that is shared and developed through collaborative networks. Very brief definition, which I like, but I also like to say that that's probably my quotation from Eiffel's, one of the annual reports was, open science is a science done right. So if we do everything in a proper way, in a transparent way, in a reliable way, then everything is done right. At the policy level, of course, in many parts of the world, open science is already a standard. And you, of course, have to mention European Union, where open science is promoted everywhere and open research culture is promoted everywhere. Huge resources are invested into building this open research culture on different levels, right? But it's not only European Union, because a very nice example that this year, 2023, is the year of open science in NASA. Yes, and with the support of Center of Open Science in the United States. So it's also quite a huge step, because we know that NASA is, of course, a governmental agency. It's not an independent one, right? So why everyone is running in this direction? Because open science offers many advantages. And one of probably the most important advantages for Ukraine is bringing back trust in research and researchers. Because Ukraine now, if we meet a person on the street in any of Ukrainian cities and we ask about what they think of, are they aware of recent developments of science, who are our prominent researchers, probably the answer will be no, we don't know anyone. Also, several weeks ago, a major news outlet in Ukraine, Ukrainska Pravda, Ukraine's Truth, published a rating of top 100 influencers, like leaders in times of war. And there are not a single researcher in this list, which is probably a very strong diagnosis for the whole research system in Ukraine, right? Also, of course, it's a greater visibility and a potential impact of research, which is very well needed in Ukraine, and also increased efficiency and scientific process, because when we know what our peers are doing, when research is pre-registered, when everything is done in a transparent way, we can reuse research outputs of our colleagues, data sets, code, whatever else, right? Also, and don't reinvent the wheel every time we are doing research. Also, and I think that for Ukrainian war, impact, research impact is one of the most crucial things. So impact is a demonstrable contribution, right, that science makes to society and economy. Of course, there is academic impact, like when researchers influence other researchers. But for us, and that's super important thing, economic and societal impact, of course, right? So this impact can be in different ways. But from my perspective, Ukraine, okay, so I was, at some point, I was asked at one conference, I was asked a question, if science can save Ukraine in times of war, right? No, it can't, but what science can do, science can help make better decisions. And better decisions are crucial for the victory, right? So for me, this impact is the most important at the moment, but also look at the, many other things, environmental impact, because we have many challenges, environmental challenges now in Ukraine, like the power station which was blown in Kakhovka, which needs proper approaches to rebuilding, and many other cases, impact of war as well. So generating new knowledge is not enough. We have to learn how to share it, right? And if you want it to be used and generate impacts. And this is, of course, very connected to open science, because it helps to increase it tremendously. So open science had already proved itself to be quite effective in approaching global challenges, starting from COVID-19 to other disasters, climate change, and many other things. So it also recognized as one of the ways and potential ways of rebuilding war-torn Ukraine. And actually, there is a very specific direct recommendation to implement, fully implement UNESCO recommendations of open science in academies who suffer from war. And Ukraine, of course, Ukrainian academia, like in general, is one of those. For me, it also, if you're speaking on the more general level, I very well remember the switch to Web 2.0, right, which happened several decades ago, when we had web which was only read web, and then we came to web which is read write, let's call it like this, and collaborative. So for me, Web 2.0 and open science has many things in common, because they bring paradigmal shift, and during this shift, there's a change for relaunching the system, and Ukrainian research system and Ukrainian academia needs this relaunching, because we have still lots of post-Soviet inertia, we have lots of ineffective things which needs to be changed. So how to do that? How to build this open research culture in Ukraine? Fortunately, we already have some progress. Of course, we have our National Open Science Plan, which was adopted on the 8th of October 2022. Why I remember this date very well? Because it was the day when Crimea Bridge was damaged for the first time, and it was such a nice day for Ukraine, but also with Open Science Plan, right? So many things to celebrate. But of course, plan is very good, but we understand that there are several barriers to open science. And what are the main ones? Of course, the war, right? I mean, that's everywhere. That's we have to, it's always with us, right? So we don't even need to articulate this, because we all live in this environment. But generally, lack of credit of acknowledgement is probably the main thing. So because let's think about, for instance, a PhD candidate who is trying to write and defend his or her thesis. So why this person should even try to practice open science? Don't know, because before it's in the rules, before it's in the system, before it is incentivized and rewarded, we cannot ask for this. This, of course, can be on volunteer basis as part of one's ideals. But if you want the systemic change, you need this in regulations. Also, lack of knowledge, understanding. We are working with this particularly with Optima project, I will try to then describe this, but of course, state level activities are also needed here. Lack of skills, we need trainings, and I will then tell you about a little bit about Optima project, but we need like trainings which are ideally open educational resources and will help to promote these things in Ukraine. Lack of infrastructure is a very painful thing because it requires lots of investment, and lack of resources finances time, because open science needs money and nothing is free. And when people think about like free something, no, it just was paid by someone else. And we need to understand that Ukraine needs to take this funds somewhere, right? So, and also the very important thing that in this process of building open culture, open research culture, from one perspective, early career researchers, young researchers play a crucial role, because early in research career, it's an ideal time to build skills and actually build an open scientist if you want, right? But also there is a challenge because early career researchers, young researchers are generally much less knowledgeable about everything because they are just early career researchers. It's very, very logical. And they are, of course, much less knowledgeable about open science. So we need to focus on them specifically. So several words about Optima project. We try to fill in some gaps, especially regarding knowledge, educational materials. We already have like draft handbook online, which will be soon published in a nice way and distributed. Of course, it's an open educational resource. Also, we are now working on the open educational resource on the base of Sumy State University and their platform Examinarium. We have also contributed to building some infrastructures, and I want to promote our open peer review platform, which is quite successful at the moment, and we already have many successful interactions on it. So please welcome, and we will continue this process, of course. If you mind, I will also share our our survey, which helps to identify what aspects of open science are more popular, less popular, and actually to just take the temperature, if I may, in Ukraine on this. And of course, we will publish everything and analyze everything in an open way, which will be published in open access, and every Ukrainian institution, individual will be able to benefit from our knowledge and actually correct their tactics or strategy if needed. So about open science infrastructure, as I already said, it costs huge money, and we see how much money European Union is investing, right? So European Open Science Cloud is a huge platform which is called like Web of Fair Data, if one of its main features, but actually that's a federation of services which helps researchers to cover many aspects of their life, research life, right? I don't think that at this point Ukraine is able to come up with something even close to European Open Science Cloud. So our main goal probably can be to try to get there, especially given yesterday's very positive developments in Ukraine's Euro integration, right? There are smaller projects, but also very important, such as OpenAIRE, Zenodo, which is built by CERN, which is a repository open to everyone, and Open Research Europe, an innovative publishing platform of European Union. There are many others, but these are ones I know better, right? So, but as I said, without changing rules, nothing will be changed. And changing rules is the most important, the key thing for changing and developing culture. So probably, and I believe these topics have already been mentioned today many times. So there are several initiatives and manifests, such as DORA, San Francisco Declaration, Leiden Manifesto, and others, which try to, let's say, change the focus from qualitative indicators to quantitative to qualitative, and help to prioritize open science. So, and recently, last year, QARA, the Global Coalition for Advancing Research Assessment, was established, and I believe that this will be one of the key communities, one of the key organizations to actually make change happen. And there are several commitments, but there are 4 main of them. So like in a nutshell, they want to diversify the contributions which is counted, not only papers, but research data and many other things. As I said, move to qualitative evaluation, abandon inappropriate use, actually use of impact factor, Asch index, which is ridiculous at the moment, right? And avoid use of rankings of research organizations in research assessment. So actually, they want academic community to focus on research and not on proxy indicators, right? In Ukraine, we already have 10 signatories of COAR, and we have COAR chapter Ukraine, which tries to lead this change, and we already have some developments, but also we have Open for UA project, which aims at implementing change at structural level. So like very briefly, the objectives promoting the growth of Ukraine's knowledge economy, because everything, of course, is about progress here, and for post-war recovery by reforming higher education systems. So we have many inspirational partners, both in Ukraine and abroad, but 3 main objectives. So we're developing draft laws of Ukraine to change the system. We are developing institutional toolkit, change on national level. So recommendations for COAR principles implementation, for certification of higher education institutions, open databases and other tools. Also developing institutional toolkit, which will be very easily implemented in any research performing organization, higher education institution, institute, everything else. And so that are our main steps we are doing, and I believe I fit it in 20 minutes as designed, right? So as I said, so many thanks for your attention, and you're more than welcome to approach me if you have any questions or would like to discuss any collaborations via this contact information. Thank you for your attention, and if you have any questions, you're more than welcome to ask.
Dear Alexander, many thanks for your presentation, for the state of art of Ukrainian open science landscape as a part of landscape or European and world landscape. Yeah, first of all, I want to say that I'm proud to be a part of team of Optima project, and we have a very important step now. We have the survey about the awareness of open science and academic territory in Ukraine. It's our 3rd survey, and Alexander spread the QR code and other information, and all Ukrainian partners, all Ukrainian participants are more than welcome to vote how what is academic integrity and open science in Ukraine. And I have a question. You mark that at the end of 2022 with other very good events, yeah, about the Crimea Bridge. Yeah, we received the plan, yeah, national plan for development of open science environment, and you told that we have some barriers. Yeah, it's a barriers on the national level. My question is about the individual level. How to increase the level of awareness by the individuals. We know something what we should do on the national level with some algorithms, some plans. But for me, for example, as an individual, what are my first steps to increase the level of awareness in open science?
Of course, thanks. Very good question. But I mean, researchers are generally quite smart. Yes, even yeah, and so if they understand, if they are motivated, it's not a problem. And probably one of the things we need to do is to actually explain very, very, very simple steps, 1, 2, 3, 4. Why should you do that? And when I'm speaking about trust in science, so being like an open researcher, I don't like this term totally, but it's clearly explains what we, yes. So researcher who is practicing open science, right? It's better to say. Then you have many advantages, right? So, but what we also need, especially in Ukraine, we need evidence. So it would be great to have like open science champions who can see that, okay, I'm doing this and this, and please have a look what they have. And so, of course, promotion needs to be implemented, and not only like as formal promotion. When, for instance, you are like rector or vice rector is speaking about ads, which is also fine, of course, at the university council and says, please do this and this. No, but probably some grassroots initiatives. And there are several initiatives in Ukraine who try to do that. Our Institute for Open Science and Innovation, COAR Chapter Ukraine, other things. So our projects, which are also quite nice and vibrant communities. So we need to to explain to people, right? So when they see that they need this, they will do that.
Yeah, many thanks. And you have the brilliant speech and brilliant talk is about that open science is not free for all. Open science is free for consumers and customers, but it's not free for providers of these services. And the next very significant and very important idea that we should pay for this. What is the way for paying? We should contribute to the culture of open science, and also with our materials, our educational courses, so on, so on, because we are ready to have something from open science initiative, but we don't ready to contribute. Yeah, and it's some obstacle, and I think we will realize and we will achieve the success in this point. Thank you. Dear colleagues, do you have other questions?
I would like to ask a small question.
Yeah.
I would like to say that your report was very interesting for me, especially because it's very recent problem about data. For me, as because I have some students that write bachelor works, and also for me as a teacher, as a scientist, it's very important to find reliable data. And so I also found that most resources are not so open as we wanted they were. And in such way, I have a question: how do you think what the main measures may be make in order to construct some infrastructure to achieve the results of these researchers and to have access to open science?
Thanks, Lisa, but I mean, you already have the access to open science, believe me. So it's only, I mean, it's only the question how, what are your needs? Because of course there is, let's say, disciplinary differences, right? Because I have just posted a link to research data. That's like a registry for research data repositories. Which is quite, I mean, popular, and there you can of course find data repository where you can share your data, but also data repository where you can find an open data set, because sometimes it's much better not to, as I said, reinvent the wheel, not to, because collecting data is costly, believe me. It's very costly. I mean, it's costly in terms of your time, in terms of, but sometimes you don't need to do that, because already you can use already existing data set. It's quite good. And for instance, if you want to build a model, I don't know your field of research, but probably for computer science, for information sciences, right, for mathematics, you often need data to build some experiments on this. And you can use already data, which is open data. It's completely eligible to use it because it's under an open license, probably Creative Commons license, right? So that is a good thing. Regarding Ukrainian infrastructure, yes, we still are lagging behind, but I know that there are several initiatives, and now our government is building a system which is called Nauka.gov.ua, and I communicated recently with Sergei Zharinov, who is probably team lead of this, and so it will not, of course, answer all problems, but this will at least provide some basis for researchers to be registered somewhere, and this will also be used in research assessment, because many indicators can still be like taken from this system. So yes, of course, many steps needs still to be taken, but you already can practice it. You can be, as I said, if you want to publish something openly and you don't have even if it's not like a proper journal article, but it is a report, it's a data set, please go to Zenodo. They will give you a free DOI, so it will be citable. It will be like we always publish there everything. So if it's not like a proper again, what is proper journal article? It's also a question. If it's not like something regular
and public.
Yes, of course, it will be open access. CERN like pledges to stay in it forever. Before the collider like not explodes and killing, of course. No, they will sustain it for quite a long time. So please, and there are many services online which are offered for free for users.
Yeah, right? Of course, I know it. But if we speak about the most recent statistical data, it's not easy to find.
Yes, of course, but for educational purposes, you don't need recent data.
You can find millions of theory, but statisticals and something really important, it's not so easy to find. As usual,
I agree with you.
Pay.
Yes, many data is paywalled, but the general idea of open science is not that everything will be open. No, open as possible and closed as necessary. There are many datasets which will never be open, especially particularly like which concerning like medical data, personal data of people, and they will never be open. And open science is completely fine with that. But what can be open should be open, of course, and that is an idea. So that's the main imperative, if may.
Yes, thank you very much.
Thanks.
Thank you. Yeah, what can be open should be open. Yeah, it's a brilliant phrase from you at the end of our first session, Alexander. Many thanks for your participation, for your speech. It's the description of our landscape and where we are. Future. Yeah. Dear colleagues, Alexander, thanks again. Dear colleagues, we have the small break because due to the unexpected situation, we removed some our session 1, and we have the break during the 1:20 p.m. I want to ask you, don't leave us, don't leave this environment, because if you want to connect again next time during from our second session, our technical support should do many work to recognize you. That's why please stay here, and we will meet after the 15 minutes, 1:20 p.m. Small break, and we will continue our session. Thanks.